I want to welcome everybody to our Phantom Academy of High-Speed Imaging webinar on Python for image processing and analysis. My name is Kyle Gilroy, and I'm here with my colleague, Saba Adabi. We are application engineers working for Vision Research. And the goal of this webinar is to essentially introduce you to some fundamental concepts of how to work with images in the Python architecture, and also to be able to control and talk to a Phantom camera through the Python interface. The topics that I'm going to cover more detailed is just getting started with Python, the digital image as a matrix, what is the difference between a monochrome and a color image, getting images and videos into Python, basic image handling and analysis examples, specific examples with Python Cine files. In particular, we have a variety of sample demo scripts that we're going to go through. A short list is here. We're going to go through a Hello Phantom Python script, a script that allows you to import directly a Cine file into Python, and then finally a Cine Frame Viewer GUI package. And we're going to finish just by talking about some open source packages that allow you to do some advanced processing on your images or video files. In particular, packages like digital image correlation, particle image velocimetry, PTV, sizing, shape analysis, etc. So one thing we're not going to cover are some of the fundamental definitions and operations typically used in coding. All right. So we advise you to take a look at, if needed, the Harvard's Python Basics course, CS50. The link is provided there. And it essentially covers an introduction to all these topics, things like functions, variables, conditionals, loops, etc. And you could take this and follow up with this webinar if need be. All right. But that webinar is hosted by Dr. David Milan. And specifically, we're going to be talking about just images. All right. And then finally, we're going to finish with an introduction to the Phantom SDK or software development kit. We're also planning on having future Python training courses, in particular, with a high-speed imaging application focus. So if you wanted to do things like size, shape, motion analysis, also things like DIC and PIV, we're going to be covering them in the future. All right. We also have a real-time image analysis course lined up as well. That will be hosted by my colleague, Matt Vayner. And that will cover how to use a Phantom machine vision camera together with a Python architecture to do things like real-time image analysis and or long record time for high-speed cameras. We'll also give you a handout after the webinar. It'll include a link to this webinar recording, a step-by-step PDF on how to install the SDK, a folder with example codes, a link to the Phantom SDK, all right, that allows you to do things like install Python SDK, MATLAB, LabVIEW, C# and C++. All right, in particular, it's going to have what we call a wheel file that'll allow you to install PyPhantom into your Python environment. Lastly, you have a direct line to the Vision Research applications team if you need any assistance with developing your code.
Python is a very powerful programming language, considering the classes. It's an object-oriented one, and it's ideal for prototype development and also other kind of programming tasks. You can also use Python as an embedded language and create different graphical user interface to use it. Since Python they developed a lot of libraries and packages for image analysis and data and image processing. It is ideal to use it for the sensor control, like cameras, and also image and video data processing. So Python can work with most of the operating system from Windows to Linux, and it is a open source package.
So on a very high level, the two common Python workflows that we mostly see people inquire about are the following. So folks like to either take their video or image files and directly put them into Python. And then they'll do some sort of analysis on that. All right, that's very common to see. Other folks want to be able to control the hardware using get set functions in Python on their PC, and at the same time do analysis or display or some processing on their images on the fly or in post. Okay, for this, you would need to use the software development kit that we're going to talk about. All right, but these are the two common workflows that we see folks using.
Okay, let's see how we can get started for the Python and coding and scripting. First, you are going to need the Python. You can either use the Python foundation, or you can like use some distribution of that. Anaconda is one of the very famous one that facilitate and simplify the packages, the package management. And it's also suitable for scientific computing. So you can download Anaconda from the link that is provided. Then you can use the IDE of your choice, which helps you to debug and also debug your code better. They will provide a console that you can use to see your variable plots and whatsoever, and you can choose whatever you desire. But what we are going to talk about it in this course is the Spyder IDE. So as Kyle mentioned, for using our Phantom SDK, you are going to need our the Phantom SDK wheels, which is a pre-built archived binary package in binary format for the Python modules and libraries. It is easy to install, and you don't need to compile it from the source file. In addition to that wheel that you need to install, you're gonna need some other libraries to working with images, like OpenCV or Pillow, and also a library for working with multidimensional arrays, which is NumPy. Optionally, you can install Pandas, which provides you a lot of method and object to work with the time data series. And finally, with our Python course, there are some examples and also demo script that will be provided that you can use and try them later. Okay, now let's see the Anaconda distribution and Anaconda navigator. You can in the home you can see there are like some environment that you can select. If you want to create an environment, you go to create, and when you are opening it, you can like name the environment and choose the package, the Python packages version that you are going to use. For example, in for our SDK up to now, there is the wheel is 39, and the Python version should be 3.9. Using the pip install, which is a versatile and useful installation command, you can install, for example, different libraries. Here is PIL. PIL is the Pillow, which is one of the image and data processing command.
So let's take a look at the Spyder IDE Okay, so if you've used to working in, for example, MATLAB, it has a very similar interface. So on the top bar here, we have all of our Python scripts. Okay, these are the scripts that we're going to be working with later. All right, unique to Python, you'll see it has that .py file format. All right, so that's how you know it's a Python script. All right, so right underneath all the different scripts that you have listed here, you have your text, right? This is all your script text. All right, so it has things like importing libraries, some of the functionality we're going to be using and talking about later. All right, so all of the commands you have are listed here, right? In the upper right-hand corner, we have something called our, this in particular is our variable explorer. This is extremely helpful when developing your code, because when you execute your list of all the variables, objects, whatever gets created when you execute your script, it tells you the type that gets created. It tells you the size of them, and it also gives you a lot of details about even the values, right? So you can see the full list here, and this is absolutely important when you are developing. All right, and then on the bottom here we have our console area. So this will basically present where you're running your file from. It will present any kind of printed information from your script and so on. So before we jump into any sort of coding or demo scripts, let's first understand what is a digital image. Okay. Now, for us, we understand a digital image as depicted on the right-hand side. This is a picture of an eye, and it's represented in shades of grayscale values. Okay. On the left-hand side, you see the same exact image, but represented in the form of a matrix of numbers. All right. Now, in order to be successful in coding in Python, we really need to understand the left-hand side, because this is exactly how the Python IDE will be used to manipulate images and display images. Okay, so it's good to remember that an image is nothing but a big matrix of values. Now, for the most part, when you're working with a phantom camera, a pixel link camera, all right, you have two types of images in general. You could have a monochrome image, or you could have a color image. All right, a monochrome image just has grayscale values, with the lowest number being black, the highest number being white, and then you have a bunch of mid-scale grayscale values. All right, a color image on the right is a little bit more complicated, and we're going to explain why in the coming slides. For a monochrome image, in general, it's represented in terms of bit depth. Okay, bit depth is the total number of grayscale values or light levels that you could present in your image. Okay, so for example, if you have an image that's an 8-bit image, if we want to know the total number of grayscale values, you would have the number of 2 to the 8th, which would give you 256 different gray values, all right, with 0 being black and the brightest being 255, all right? For phantom cameras, for the most part, they are 12-bit images, all right? 2 to the 12th power is 4096. So you have 0 being black, all the way up to the brightest pixel value being 4095, all right? So you have 4095 different possibilities of grayscale values. Each step is an integer value in that scale. Digital images, digital color images are a little bit different, all right? If you save it as, for example, a TIFF file, all right, this is a color TIFF file. What happens is this color image is represented as a stack of 3 colored channels, all right? If you're working with the OpenCV library, which is among most popular libraries that we work with, you have the blue channel represented as an 8-bit slice, okay, represented by the indices 0, okay. You have the green channel it's an 8-bit green channel represented by the channel 1, and then you also have an 8-bit red channel represented by channel 2. All right. So essentially, these are superimposed images that are displayed to you, and then our eyes are tricked into seeing a full color spectrum here. All right.
So now let's see how those color images are created. They are basically use what we call color filter arrays, which is a mosaic of color filters that overlays the pixel comprising the sensor. And what they do, they limit, basically limit the light intensity with only one wavelength going through, and they normally come in forms of green, red, and blue. And then what they are using is a technique which called interpolation, and it's basically construct the data point, the data point within a data set that are missing, and it can be like from a simple, using a simple nearest neighborhood technique to like a complex polynomial interpolation technique. And then what you are seeing as the color image is the interpolated data. While some people, some scientists prefer to use the raw data, which is uninterpolated data coming from a single channel, and if you zoom in to that data, it's like a checkerboard. You can see the different types of image coming from like different camera. The first one is from monochrome camera, single channel, while the next one is from a color image, interpolated one, and last one is the Bayard raw image from a single channel of color camera.
So now that we understand the different types of images that get created from these cameras, let's start to talk about how we can understand it in terms of in Python. Okay, so when we code up in Python and we define images, really what we're defining the images as our matrices. Okay, so here we have a matrix called M. All right, and we are going to represent all the pixel values as elements in this matrix. Okay, so for example, in the upper left-hand corner of this matrix, we're going to have M00, 0, whereas that represents the row and the column. Okay, so if we go across here, we can see that we have M01. Again, this is represented as row 0 and then column 1, and so on and so forth. All right, and it can get a little tricky if you write a lot of code in MATLAB. MATLAB starts in indices of 1, which for images is more convenient, but in Python, everything starts at 0. Okay, so if you look at this image, it could be represented as a large matrix of values here, like you see here. So let's say, for example, you wanted to take this image that's stored in a matrix and you want to grab a single pixel value. Okay, let's say we want row 600 in column 50, right? Once we store this image in the variable M, all we have to do is call that variable M, and because we start at 0, we have 599, comma 49, and then our code will tell us that the pixel value at this level here is, for example, maybe 324. All right. Now, color images, like I mentioned, are a little bit more complicated. All right, and the way they're handled is by adding an additional indice. All right, so we have the same format where we have the row here, column here, but now we have our color channel on the tail end. All right, so if you wanted to grab a pixel value from a single color RGB image, you'd have to indicate which color channel you want. All right, so same thing again. If we wanted to get row 650, column 50, we could call, for example, 599, 49 for our column. And then finally, we represent our indice. We want our red channel, so we have to put 2 here, and that would grab the pixel from the red channel, okay? And again, this is the format of OpenCV, and you can see I have indicated down here, K equals 0 is blue, K equals 1 is green, and K equals 2 is red, all right? If, for example, we wanted to do the same thing for our green channel, all right, we have row 20, column 50, all right? All we would have to do is, again, type in our row, column, and then the color channel, all right? Green is 1, we get a pixel value of 114. Let's say you had a stack of images, color channels here, and you want to know the value of the same pixel in the stack, okay? So again, we have the same format. Let's say we wanted to know column 50 and row 20 again. All we'd have to do is call those values again, f of 19, comma 49, and then we would just put a colon here that says, I want all the values in this particular element, all right? And then it would pop out all the pixel values, the blue channel, green, and red, and so on, all right? So this is the general formatting that you would use for working with images as matrices, all right? So some of the first operations you want to do in Python is just importing images, all right? So let's take a look at that. I'm going to open up Spyder. And this is a sample script that, again, it's very simple, but we're going to still provide it to you, all right? And this just shows you the general workflow of how you would import an image into Python. The first thing you always do is you define the library that you want to work with, all right? So you'd import CV2, which is your OpenCV library, okay? And then you have access to all the tools inside that library, all right? And one of the tools that you have is called a method called imread, okay? So here I have the library CV2, and I'm going to use the method imread in that library. And then I'm going to define the file position on my computer of where my, for example, my TIFF image is, okay? So I can just copy that file position, and then I'm going to read all that information into a variable called image, all right? I'm going to use another method in the CV2 library called imshow, all right? And that's just going to show me the image. And I'm going to create just this is just for the first position is just the title of my window. So title of image window. I'm going to put that variable image inside this method. And then I'm going to tell my computer to just hold on until I press any key to delete all these windows. Okay, so to run this script, all I'd have to do is click run. And here I have an image that popped up called title of image window, like we defined. And here we have a bullet going into some crayons, all right, because that is what the TIFF image was in that file location, all right? So that is what we would recommend for a first step. If you're working with Python, just make sure you can import an image, okay?
Okay, let's say you want to see different channels. So what you can do is, after importing the OpenCV, as Kyle mentioned, you can read the images from the directory that the file is saved to M, for example, and then to get each of those channels, you just need to get specific indices. For example, 0 is your first channel, which is the blue, 1 is the green channel, and 2 is your red channel. And by putting that column there, you just mentioned you need to get all of those rows and columns from that method. And now you have each of those channels in saved in those variables B, G, and R, and then you can show them. For example, if you want to see them in different channels, let's run the code. Okay. Now, now if you can see, so this is our initial image, and then we are separating out the red, blue, and green channels that you can see. And then you can use the destroy windows to close up those. So you can use lightweight key that the windows won't be closed like immediately, and then you can close them with destroy all windows.
All right. And we have here in the PowerPoint that we're going to give you just a step-by-step procedure of how everything is done, so that if you want to reference back, you can easily just look at the PowerPoint and run the sample code to get it all working well. Okay, so why would you ever want to do something like that, a channel separation? You know, one really neat application that we work with is something called 3-color PIV, where we have users basically hitting particles with a pulse laser, and they have pulse lasers that are that shoot pulses of red, green, and blue pulses. All right, and those are temporarily delayed within the integration period of a frame. So what you can then do is separate out the different color channels, and they're essentially different temporal locations for each frame. So you can do really neat particle image velocimetry on this data. All right, so here's just an example frame that we had from a recent test. All right, so as you can see, here's a spray being sprayed, and on the right-hand side here, you can see each particle is represented as a different color triplet. So for one particle, you have a red, a green, and a blue channel, temporally spaced by the pulse delay of that test. Okay, so very, very useful from an application sense. Okay. What's also very important is the ability to create images. All right, so importing images is one thing, but inevitably for doing advanced analyses, you want to be able to manipulate the pixel values. Okay, so I'm going to open up Spyder again. I'm going to go to my Python script called create display matrix. And what we can see here is I'm going to import a library called Pillow. Okay, and I'm going to import a specific function from that called image. I'm going to import another library called NumPy array, and I'm going to represent it as NP. Why do you have it as NP? Just so that it's shorthand, so you don't need to keep on writing NumPy every time you use a method inside that library. And then I'm also going to import CV2 like we did before. Now, if I wanted to create a monochrome image, okay, what I can do here is simply define the width and the height of that image. So let's call it 100 by 100 pixels. I'll initialize a NumPy array of zeros with the height 100 and 100. And then I'm going to have the data type in there be represented as 8-bit. Okay, so we just do D type equals NP dot unsigned int 8-bit. Okay, and then what I'm going to do is I'm going to fill this data matrix, okay, data mono here. And whenever you see, for example, a pound sign or a hashtag, whatever you want to call it, that's just a comment. All right, so here we have data mono bracket from pixel position 33 to 66 and pixel position column 33 to 66. So this is all my rows and all my columns. I'm going to create a pixel value of 255. And that 255, as you recall for 8-bit, is a white pixel. All right. Now my NumPy array of zeros is just an image of black. All right. And then I'm also going to create another white swatch from 0 to 10 rows, and then from 0 to 10 column here. All right. And then what I'm going to do is I'm going to display that to the user. Okay. And I'm just going to do immono.show and display it. Okay. I'm just commenting out some other things I'm going to show you in just a second. And I'm going to run that code. And I'm going to give Microsoft Teams a minute to show that. It's already displaying on my computer. And I just created an image with, again, all black pixels. And then I painted a small white swatch in the upper left. And in the middle, I created that little white swatch. All right, so this is just an example of how to create a monochrome image. If I wanted to create a color image, I could do the same thing, except I'm going to initialize a new matrix called data color. I'm going to create a NumPy array of zeros with the height 100, width 100. Now, instead of having no indice in the third position, I'm going to put one because I have colored channels. Okay, so I have 3 color channels, and I still want to make that data type 8-bit. And now what I can do is fill that matrix up with values. Okay. So if I wanted to, I can create from 0 to 10 row position, from 0 to 10 column position. I have, now that I'm using NumPy, their format is RGB. So I'm going to put RGB. So this is going to be the max value, 0, 0. So this will create a red square in the upper left position. From 10 to 90, from 10 to 90, we have RGB. So I have a big green square in the middle position. From 90 to 100, from 90 to 100, I have a blue square. And then finally, from 33 to 66 rows, from 33 to 66 columns, I want white. All right. So I just created a really interesting image. Okay. And I'm going to show that to the user. Okay. Just by using image color show. So if I run that code, I get this image pop up. And I just essentially filled up a black image with colored pixel values. All right.
Now you worked with only like one image, but now let's see how we can get multiple images into Python. So you can use like very powerful and useful library called Globe, and then with using Globe gives you the information about the directory of where your specific format of image file are saved. We are saving them in that variable path and in that array, and then you can iterate through those number of images and read them to the temp image list, which is initialized as image list, and then populate them using the append method of the list. Then you can like see them or like later manipulate the images that you have. Let's go to the Spyder, and then I can run the code for you. Just Give it a minute. Okay. This is for example, the path is where we are saving our files, and we are iterating through all of those TIFF files, which is on that directory. And you can see, for example, I showed you the different images, which is saved on the 3 first images, which is saved on that file. Okay.
Okay, and so that's a really nice way to get multiple images into Python. Okay, I'm just waiting for Teams to update. Give me 1 second. It's taking its time. It's not our friend today. Yeah, sorry guys, still updating. Okay, great. So here we have the code that Saba just mentioned. So if you wanted to get multiple images in the Python, you could use this globe.globe function, and it's very efficient to create a list of images. And we just showed you how to display 3 images in that list very quickly. Another useful thing I want to show you is that if you're in Spyder and you're looking at when you're looking at the different variables that get created, you can just look here to see how it's working. Okay, so here we have that path variable, and it gives you all the information of what's in there. So what the path did is essentially store a list of file locations. And then the for loop essentially saved each image at that path location into that variable. Okay. Then what you can do is you can look at what that list looks like. So that list contains just a list of images, and you can see exactly what their size is, if they're 8-bit, 16-bit, or so on inside that list. Okay. And then finally, it's always good to test to make sure there's images in there. So if you run the code, you'll see your images pop up from your list. So how do you pick through lists? All right, now that you have a big old stack of files, all right, let's see how you could do that. All right, so if you, for example, have a list called P, all right, if you want the first image in that list, all right, I'm sorry, if you have a list called image list and you wanted to store just the first image of that list inside P, what you could do is just run this code and you're going to store that image there. All right. Then if you wanted to, you could call specific pixels from that variable. All right. From 30 to 600 rows, from 30 to 600 columns. All right. And then this specific color channel, the second channel. All right. That would create a region of interest. All right. And it would save that into the variable ROI. You could take it one step further, and you could absolutely just do both of these commands in one. Okay. Waiting for Microsoft to update. Yeah. There it goes. So you see we have now image list 0, which is your first image. And then in brackets to the right of that, you have the description of which rows, columns, and channels you want to be selected. Okay. So if I display that in Spyder, I'll see a region of interest pop up like that. And that image represents the position 30 to 600 rows, 30 to 600 columns, and then the third image channel, or represented by Python, the number 2. Okay. And we have here also, for your future reference, we have the image number, row range, column range, and so on represented for you in case you want to refer back to this. Okay. Here's some more useful methods you could use and functions in list format. So let's say, for example, you're working with frames and you want to get all the frames in your list. You would use that colon symbol. All right. So that would grab all the frames from that list. If you wanted the first 10 frames from the list, you could use :10. That would grab the first 10 frames. If you want the last 10 frames, you could do -10:. If you want a range of frames, you got from 100 to 200. If you want every 10th frame, or if you want to do something called decimation, you would do ::, and then the decimation. For example, this would be every 10th frame. And if you wanted a list of specific frames, all right, what you could do is use 2 brackets and pick the frames that you want to grab from that list. So you have 100, 107, and 113 in this particular example. Okay.
You saw some practical examples using different libraries. So I'm here just summarize what you can do with like 2 main libraries. The first one is OpenCV. As you saw, you can use, you can read, plot, or write the images using different method in OpenCV. You can do like more arithmetic operation on the images. Also, as you saw, you can access and modify the pixel values. You can also change the color spaces using CVT color, and or you can do like more mathematical formulation like filtering, thresholding, transformation, or other things. And if you want to do like more advanced thing, you can also develop use the OpenCV and its tracking algorithm to track some particles or the specific object. For NumPy, which is basically a library which developed for the working with the multidimensional array, and it provides object and tools to work with that array. It has like a lot of powerful method that you can use. You can like get information about the type and shape of that array, do different types of mathematics, and also, as you saw in the examples, do indexing or slicing to get like a specific portion of data. And also you can do like array manipulation, like reshaping, resizing. You saw append, or even like insert, delete, or split like different, for example, channels.
So another really useful thing in the library OpenCV is handling live images. And this is something I highly recommend when just starting out and you want to be able to manipulate a live image stream. Okay, so I'm going to open up, yeah, you can turn that on. Great. I'm going to go ahead and open up Spyder again here. And OpenCV has a method called video capture. And what it'll do is it'll actually grab any USB-based camera that is compatible with this method, and it will store it in the video object. Okay. And what you could do is display that live frame to the user or to yourself as in a while loop. Okay, so what you could do is use the vid.read function to read that live image into a variable image, and then you can display that constantly while in the while loop, or until you break that while loop or press, in this case, I had the user press Q. Now, at the same time, I can do some advanced analysis. Let's say you're working on an application where you need to split your live image into the RGB channel or the BGR channels. Okay, and you want to display a live histogram for whatever reason. You would use, for example, inside of your matplotlib library, we have a method called plot, and we can display a histogram from that library. So if we run this code, okay, we can see here, you guys get an excellent view of beautiful New Jersey. Okay, we have a fan sitting next to a window, and we have a live view of that fan blade. Okay, and if you look in the upper right-hand corner of your Spyder IDE, you can stick your hand in front of the camera and you can manipulate the histogram. All right, so this just gives you an idea of what kind of live image operations you can do with only a few lines of code. Okay, so I'm going to close that. And now what we're going to do is jump into Phantom specific libraries.
Okay. Up to now, we just talked about getting images or videos to Python and like how we can like handle and manipulate them. But now we are going to talk about what is our Phantom software development kit or SDK, which is basically designed for the software developers who wants to write their own apps to control Phantom high-speed cameras and also develop algorithm or technique for playing, analyzing, or do measurement on our Cine files. This SDK comes with contain the libraries which are in forms of the dynamic link libraries and on top of an object-oriented layer, and also there are some demo script and example that user can use to start with our camera. In our Phantom SDK, you can configure the camera parameter. You can get or set acquisition parameter like the resolution of the camera, the frame rate, exposure time, and etc. Also, you can send record or trigger commands to the camera, get the live and recorded videos, and after saving the images, you can do like more analysis and processing on the videos. Our Phantom SDK main libraries are phcon, phfile, and phint. phcon basically control the cameras, set the parameters, and for transferring the data, while phfile works with file and movies management and saving them. The phint is a library which provide the image processing for our SDK.
So there's a lot of different file types out there that we're aware of. We've all heard of, for example, JPEGs. You may have heard of BMPs, PNGs, TIFFs, and so on. Okay. All these file types serve different purposes in the past. Okay. But really, you can broadly group them into how compressed and how lossy they are. Okay. So for example, you have BMPs, which are uncompressed and lossless. Okay. Whereas you have JPEGs, which are compressed and lossy. You see a lot of folks working with TIFF files, and you can actually define the degree of lossiness in a TIFF file. Okay. But for the most part, what separates out the Phantom file, called a Cine file, is the fact that we give you the ability to not only save the uncompressed raw data, but it also has all that great metadata from your test. So it has things like your frame rate that you recorded at, It has things like the model number of the camera, the exposure time. Okay, all that is in that Cine file format. Okay, and unlike a BMP or a JPEG, the Cine file is not readily importable into the different types of coding environments like MATLAB or Python. So that's why we need, for example, the Phantom SDK to bridge the gap between that proprietary format and these coding environments. So Saba is going to show you right now a sample script that we recommend that you try. And this is called Hello Phantom. So go ahead, Saba.
We are called this small script Hello Phantom because first time that the C programming language creator wanted to test if the code is compiling and working well, they use Hello World. So we use the same analogy and wanted to show you how you can connect your camera using the Python Phantom SDK. The first thing that you need to import, as you know, is the required libraries. For our SDK, you need to import from the PyPhantom, the Phantom utilities and Cine module. And then which each of them works. For example, the Cine works when you want to use like the Cine handles and all of those functions that you can get or set. Phantom works without camera. Then you can import like optional libraries. Here I import time, NumPy, and OpenCV and Matplotlib to show. If you want to show, for example, some plots in your code. The first thing that you need to do, you need to make a Phantom object and putting all of those handles in the specific variable. So if you have a camera connected, this PHDiscover shows you the serial number and all of the information for that camera. Otherwise, it will connect to a simulated camera, which you can define it. It can be like a mono or color one. So now I'm going to run the code and show you. To run the code and show you how this Discover give me all the information about the camera that it's already hooked up to our PC. So the first line is, yes, now you have a camera connected to this laptop, and then it gives you the name of the camera, the serial number for that camera, the model, which is a T3610, and the number of camera is connected, and also the hardware version of that camera, which is written here. If you go to PCC and check if those variables are correct, you can see in the camera info, all of those variable is as shown in your Python console. Okay. The next script that I'm going to show you is, for example, if you have like a file, a Cine file, which is saved on your desktop, you can import that Cine file and do whatever manipulation you want. For example, show some frames of that one, and also get and set all of the information about the metadata of that Cine file. One more libraries that I imported here is Pandas, which is works with time series, because I wanted to show you the time of the camera. So I'm going to initialize the Cine file and all of the frame within it in a huge list first, using this file that underline select dialog. It allows you to select the Cine file using a dialog box, and then you can use like the method from the Cine module to save your Cine file in this Cine one. And to get all of the frames, you can use the range method from the Cine, defining from, for example, start from the first to the last one minus one, and then append all of those frames to this list. So this append method creates for us an extra dimension. If you want to suppress that, you just need to use the squeeze method within the NumPy library. And then I'm going to show you the shape of that, which is the size and number of images on that Cine file, and also other information like plotting some frames from that from the Cine file, which I'm going to select. So let's see what we are getting from this function, which I wrote to get the acquisition parameter and also the time stamp of the camera. You can see if you use the Cine module and its method like resolution, post-trigger frames, like frame rate, serial number, range, and also if you have like some other function like get the time stamp. And if you wanted to display it, you can use the Panda timestamp method from the Panda libraries to show it. Also, we'll get the brightness, contrast, and gamma from that source. So let's run that code. And you need to select a Cine file, which I'm going to select, for example, this one, which is a mono from a mono camera. Okay. In this code, what I'm displaying is all of the frames within that Cine file, and then if we go up, you can see all of the information about the metadata and information about that. Information about that Cine file. So as I said, you can get like the shape of that that tensor. The first one shows you the number of images and height and width for that frames, for each of those frames. And then you can see the resolution parameter that's set for this Cine file, the number of post-trigger frames, the frame rate, exposure time, and also the timestamp of the camera, brightness, contrast, and also the bit per pixel, which is used to saving this Cine file.
Another script that we put together here is called Cine File Viewer GUI, and the purpose of this is just to provide you a sample script to shuffle through the different frames inside your Cine file. All right, I'm going to spare you from going through this, but it is useful to look through if you're interested. So if we run this, for example, okay, and I already have a file selected in the script. What it will do is it will read that Cine file, and it will open up a GUI like you see here. And then if you just click on your arrow key, you can actually cycle through all the different frames that you have in your Cine file. Okay. And you can even use your mouse to scroll over the pixel values to get the coordinate of that cursor position and also the pixel value. Okay. So it's a kind of a useful technique just for displaying all your Cine data. All right. And once you have access to all this data, you can do all sorts of analyses on it as well. Okay. And I just press escape to get out of that.
Just know that in addition to the script that we showed you today, there are also other examples in the Python SDK demo folder. And if you want to know about most of the methods and properties that we develop, you can go through this all method and properties.py. Which shows you how you can use the different modules that they are developed. If you want to use like camera modules, you go to the cam, and if you want to see the like using the Cine, you can use the Cine to do that. Just one more thing that I want to mention is when you are installing your Python wheel, it should be the Python wheel gives you information also about the Python version. So the Python version needs to be as it's required for the Phantom SDK wheel.
And then the last thing we want to mention is that we have a ton of users doing very interesting analyses on their Cine files. All right. That being said, you don't always need to reinvent the wheel, right? So if you are wanting to do digital image correlation from the ground up, or maybe you want to do a particle image velocimetry script, or maybe you want to get the size and shape histogram of some particles moving throughout your video, there's already pre-built Python scripts out there that are open source and very nicely documented. I just listed a few here that you can look into. The links are in the titles there. Very, very useful. Even, for example, TrackPy itself, that will natively take Cine files into the functions, right? So even less work to do in that regard. So now we want to take any questions you may have about Phantom cameras, the Python SDK in general.